Hey everybody, just want to welcome you to week 12, module 12 for ME 144 heat transfer. Within this module here, we're going to be taking a look at chapter 7 in our textbook. So within this module, we're going to break this down into two different sections. The first section, we're going to take a look at external flow, the flat plate and parallel flow. Then in the second section, we're going to take a look at the external convection flow over bluff objects. We're also going to get into looking at some example problems and go through some of my hand solutions, and I'll post up some videos stepping through these hand solutions and relating it back to some of the topics and governing equations that we see in chapter 7 of our textbook. So some bookkeeping items for this week. We do have our quiz number 12. So this has been posted to Blackboard and it'll be due on Friday by 4 p.m. We also have our exam number 2. So within exam 2, this is going to be a new date. So this exam 2 date is going to be April 27th. And it's going to go from 9 a.m. till 12 a.m. and that's going to be the time block. And you'll have 2 hours within that once you've started it to complete it. So just take a note here that our exam number 2 that I want to mention right now is going to have a new date. We've pushed it back a little bit and it's going to be April 27th, releasing at 9 a.m. So what this is going to do is I'm giving this exam during my ME 171 class time slot to give everybody an equal opportunity to get at this and not have to worry about overlapping classes. The majority of you are also in my 171 class, so we're canceling lecture in 171 in order to give us room to take this exam here. Now, I will go into this in a little bit more detail in the next slides. Thing to note, just a reminder, I do have my office hour scheduled for Mondays from 9 to 10 a.m. If you're unable to meet during these times, please send me a chat, a message, or an email, and we'll find a time that works for both of us. Also, I do want to note that the TA has office hours on Mondays and Wednesdays as well, from 11 a.m. till 12 p.m. If you have any homework questions, grading questions, exam questions, he's the one who's doing the grading, so it'd be a great opportunity to reach out and connect with them. So next I want to take a look at our schedule for the rest of the semester here. We are getting close, wrapping things up in our final push here. So this is our module number 12. So you do see we have 2 lectures this week that we just discussed relating back to chapter 7 in our textbook. We'll look at 7.1 through 7.3 for external flow, and 7.4 through 7.8 we'll look at external convection and the flow over bluff objects. Now this does lead us into that in module 13 the following week here. We're going to have our exam number 2. So note this has been pushed back from the original scheduled date for exam 2 to give you guys a little bit more time. I know you have exams in other classes. Didn't want to pile things on top of you, give you a minute to breathe. So I have pushed this back now until the 27th, and I'll go over the details for this exam in the next couple slides. From there, we'll move on to our last lecture for the semester here, or within module 13, where we're going to talk about external flow mass transfer, and then we'll get into the last 3 lectures of the semester are going to be dedicated to your group project presentations. So we're going to break this down and give you a chance to submit your videos going through your solutions, similar to what I do in class in these video lectures for your group's problems. So we'll get into some more details with this as we get closer to our module 14. So now let's take a look at some of the milestones and due dates associated with our group project. So we come down here, we can see this first milestone. We've already completed this. You guys have formed your teams and submitted a list of the team members via Blackboard assignment. Again, these are 4 to 5 team members per team. So from this here, hopefully you guys have been working hard towards creating your problem, because that's the next milestone here. On Thursday, April 29th, this is when you're going to turn in that problem that you've created along with your solution. Now this will be done via a Blackboard assignment. And this Blackboard assignment is going to allow you to submit this as a group. So only one member of each of the teams will need to actually submit this assignment to me. As long as one of them's turned it in, they're all linked together through these teams that we've created on Blackboard. Then from there, the next milestone we have here is on Monday, May 3rd. This is when we're going to distribute your team's problem to another team to solve. So you're just going to be solving one other team's problem. So once you've completed that, your solution, you're going to submit your solution to the other team's problem back to them, and they're going to grade that for you. So you give the team that created the problem your solution to their problem that you've solved out, and this is going to be on Thursday, May 6th. And the last due date will be on Tuesday, May 11th, and this is when you're going to submit your final video presentation. So what this is going to be, this is going to be similar to like I do when I go through example problems in class. You're going to record a video of you going through your entire solution, explaining your solution, your thought process, relating it back to the governing equations, and all of that stuff included in your virtual presentation. This will be turned into Blackboard and graded as a portion of your group assignment. Now also on Tuesday, May 11th, not only be turning in your video presentation, but you'll also be turning in the graded work from the other teams that solved out your group's problems. And this will be submitted through Blackboard as well. So let's get into the details for our exam number 2. Exam 2 will cover materials from our textbook in chapters 3 through 6, which relates to our modules 6 through 12 in our lectures. So this is all fair game for this exam number 2. These exams will be released on Blackboard. So the date that they'll be released is Tuesday, April 27th. So please take note of this. The new date for this exam number 2 is Tuesday, April 27th. It will be released on Blackboard at 9 a.m. Now, once you start the exam, you will have 2 hours to complete it. And this is automated by Blackboard. So if you started at 9 a.m., it'll need to be turned in by 11 a.m. But I'm giving a 3-hour block. And the reason I'm doing this is for students that are coming from another class or going to another class. They have a little bit of leeway. So this right here will be due at the very latest at 12 p.m. So if you don't start the exam until 10 because you're coming from another class, you'll still have 2 hours, but it'll need to be done by 12 p.m. for that case. You'll submit your final work through Blackboard, and the format will be the same as you've seen on your homework and your previous exam number 1. So students without accommodations or scheduling conflicts are expected to complete the exam in that 3-hour block from 9 a.m. to 12 p.m. during that designated slot. And again, you only have 2 hours to complete it, but there is a 3-hour block. Now, if students do have accommodations, then extra time will be accommodated for them after 12 p.m. So if this is the case and you do have accommodations and it doesn't fit within this 9 to 12 period, please contact me individually and we'll make sure that you have the correct accommodations for you. Now, if you're a student with a scheduling conflict and need to start it later, this is possible, but please let me know in advance so we can schedule this. And again, you'll still only have a 2-hour block, and we'll still need to have this finished, in this case here, before 2 p.m. So this all needs to be done in the same day. I want to keep the same exam for all the students, so we're going to still use the same exam regardless of when you're taking it. So I want to keep that window very short. The other thing to note is if you are a student with an accommodation, you need more than the 2 hours, you can ignore the automated late thing, or if you're taking it outside of that normal block because you have a scheduling conflict, ignore the automatic late notification. The grader will be looking at this exam at the time you opened it and the time you submitted it to make sure it's within the correct 2-hour for students without accommodations and whatever your accommodations are for students with the accommodations, and double checking that you are within that correct time block. So as we jump into our content for Module 12, looking at external flow, within this module we're going to focus on the problem of computing heat and mass transfer rates to or from a surface in an external flow. So in such a flow, boundary layers develop freely without constraints imposed by adjacent forces. So this will be the bulk of what we're going to be looking at within Chapter 7. Accordingly, there will always exist a region of the flow outside of the boundary layer in which velocity, temperature, and or the concentration gradients are going to be negligible. So that's something we want to pay attention to and see what we can consider negligible for these problems as we start them. Now, examples include fluid motion over a flat plate, inclined or parallel to the free stream velocity, and also flow over curved surfaces such as a sphere, cylinder, airfoil, or a turbine blade. So now let's take a look at the objectives we're going to cover within this module. We want to take a look at the empirical method, then take a look and discuss the flat plate and parallel flow, moving on to the methodology for a convection calculation, looking also at the cylinder and cross flow, the sphere, and then looking at the flow across a bank of tubes, then moving on to our impinging jets and also packed beds. So these are the objectives and topics we're going to be looking at within this Module 12, related back to our textbook, Chapter 7. So now, as I've mentioned, we're going to break this module down into 2 different sections. We're going to look at Module 12.1 and Module 12.2. Within our first section, Module 12.1, we're looking at external flow and specifically looking at the flat plate and parallel flow. So within this module section here, 12.1, we're going to be taking a look at the empirical method, talking about this flat plate and parallel flow, where within that, what we're going to look at is laminar flow over an isothermal plate. We're going to look at turbulent flow over an isothermal plate. Then we'll look at mixed boundary layer conditions, moving on to unheated starting length. And from there, go to our flat plates with constant heat flux conditions. And then finally look at our limitations on the use of the convection coefficient. So we're covering all these different areas and scenarios within our flat plate and parallel flow. And the last thing we're going to look at is the methodology for a convection calculation. So within this section, Module 12.1, we're taking a look, going over the theory for these above topics, discussing the governing equations, looking at some practical applications, and then going through my hand solutions to a couple problems. So now moving on to our Module 12.2, our second section for Module 12, we're going to be taking a look now at external convection, specifically looking at the flow over bluff objects. So within this section here, we're going to cover the topics of the cylinder and cross flow, looking specifically at the flow considerations and convection, heat, and mass transfer. Then we're going to look at our sphere, Move along to our flow across a bank of tubes, talk about our impinging jets, looking at our hydrodynamic and geometric considerations, as well as our convection, heat, and mass transfer. And last, we'll finish up with packed beds. So within this module here, our 12.2, again, we're going to go over the theory for these above topics, talk about our governing equations, look at some practical applications, and then go through my hand solution to an example problem.